Station, this is Houston. Are you ready for the event?
Houston, this is Luca in Columbus. I'm ready for the event.
ESA, this is Mission Control Houston. Please call station for a voice check.
Station for voice check.
Station, this is ESA moderator Alana Bartolini. How do you hear me?
I read you loud and clear.
Got it.
Excellent. Thank you. Hello, Luca. Good afternoon. You're now connected with Germany, Italy, and Spain. I'll hand over to you quickly for some opening remarks, then we'll go to the floor for questions.
Well, first of all, hello, guten Morgen, hola, and ciao a tutti. It's a great opportunity to have you guys here. I don't want to steal a lot of time with my words because I'm really curious to hear the questions from the students, and I'm eager to answer those questions for you.
Great. Thank you, Luca. We'll first begin with our 2 questions from Germany. Germany, please go ahead.
Hello, Luca. I'm Stefan Yao from a secondary school in Kalbala. We had a huge Mission X program, and me and my students, we wanted to know, in the Bayaka Experiment, you work with microbes that break down rocks into useful minerals and metals. How do you safely perform experiments like this on the ISS, where the contents could be harmful for the crew? And do you think that experiments such as BioRock can help lead to the development of future life support systems?
Wow, hello. Well, first of all, I'm very excited that you guys know so much about the Bayaka Experiment. It's a really, really, really cool experiment. The way we deal with any kind of potentially harmful substance on the space station is that we take a very, very good care of how we contain it. So anything that is potentially harmful needs to be contained in 3 different levels of safety. So the Bayaka Experiment had a box inside which there was a container that had the water and the bacteria, and then we also performed all the experiment here in Columbus, away from the other modules, inside an incubator, so that we could spin the bacteria to see how they would perform in microgravity, or actually with the same conditions they would have on the ground under an acceleration, and floating in microgravity. So basically, the answer is we have. In the design itself of the experiment, we contain as much as we can any potential harm, and on the ground we take really, really good care of doing that. As far as an experiment like BioRock being useful for future life support system, BioRock was not designed for life support systems. We have other experiments that are going in that direction, where we want to recycle water, we want to see if we can recycle solid waste, we want to see how we can improve the stability of an environment. BioRock was really designed more as a mining idea. Like, if we are going to exploit resources on a different planet or a different satellite or an asteroid, how can we do that? Can we use existing bacteria, and can we change them, maybe modify them so that they suit our needs?
This is Jan speaking from Willy Brandt Gesamtschule in Germany. My students and I, we really would like to know, how do space missions affect you physically and psychologically, and what characteristics, knowledge and skills will astronauts need for future deep space missions?
Wow, that's a great question. You guys are very hard questions. Okay, so first of all, from a physical point of view, as you can see, I am completely weightless here in orbit, and the way it affects my body is that if I didn't do anything at all while I'm up here, it would lead to very quick degeneration of my muscle structure and bone structure, something very similar to osteoporosis, a rapid onset osteoporosis. We have other effects. We have fluid shift that changes the pressure distribution in our body, and we are studying all those effects. But the best way I can answer that is in order to avoid any changes, any physiological change, we really have put in place a lot of countermeasures during the years. That's why we've had the space station for 20 years. We have now learned that by working out every day, doing physical exercise, up to 2.5 hours every day of physical exercise, lifting weights, running, cycling, we can keep those changes to a minimum. There are also potential changes to our sight. There are possible changes to our hearing because of the background environment, and our engineers on the ground do all they can to prevent those from being permanent. Psychologically, well, it's hard to tell because we are the ones on the space station and we feel great. We have human interaction all the time, and we choose to be up here. There is no imposition. So in general, I can tell you that the crews that are on the space station are really happy to be up here. And I'm not aware of any psychological changes other than the ones you can expect. Like we miss our families. We miss, after a couple of months of being up here in a very artificial environment, we miss natural things like natural food, natural sights, smells, the rain, the wind, the sun. Those are psychological impacts. But I'll tell you what, because we do know that those impacts are not permanent and this is a limited experience in time, we actually know how to deal with that just by, talking, looking outside, sharing the experience with the people on the ground, and making sure that we stay well connected, and that's the best way to do it. Thank you for the question.
Thank you, Luca. We're now heading over to Italy for 2 questions. Italy, please go ahead.
Good morning, Luca. I'm Claudia Piantini from Secondary School Principe di Piemonte Moscati in Rome. I'm honored to meet you, and the question that my students would like to ask you is the following. For us, going beyond means overcoming our own limitation and difficulties, and also overcoming our thoughts, or being willing to change our knowledge and our beliefs. In your work as an astronaut on the ISS, when and how have you had the opportunity to go beyond your experience and professionalism? Have you experienced a personal change in your beliefs or knowledge? Thank you.
Wow, you guys really search deep for very, very deep questions. So what does it mean to me, going beyond? To me, going beyond is finding your limit, finding the side of the box that you are currently in, and pushing the limit away to the side. Try to make it bigger. We all have limits. We all do have limits, but we can push those limits away. So I hope not to disappoint you guys, but in my professional experience, the things that push me beyond are performing those tasks that I'm not very talented at because I don't enjoy them as much. We all have preferences. Some people like science, some people like maintenance, some people like more active stuff. Everybody's preference. When I get to some tasks that are really difficult for me, that's when I find my beyond. And what I mean is that by focusing on doing the best that I can on those tasks, the ones that are hard, the ones that are the most difficult for me, where I'm not good at, trying to be as good as I can be, that's to me going beyond. And here on the space station, I find it every day. There is always something that I find that is frustrating, that is hard, that is difficult, that is more complicated than I expected. It takes more time than I would like to. And that's when I have to gather my resources, get a clear head and say, okay, if it were easy, we wouldn't be here doing this. It wouldn't be interesting. So even though I don't like what I'm doing, I have to put 100% of my capabilities into this task so that I can grow, so that I can evolve, so that I can be better tomorrow than I was yesterday. And take it as an opportunity for growth. Right now, one of the hardest things I'm doing is being commander. Being commander of the space station so far has been the most professionally challenging experience ever, because we can teach anybody how to perform a task on a computer, how to do science. We can teach how to fly a spacecraft, but nobody can teach you how to lead. You cannot teach that. You have to find out on your own, and that's what I'm learning every day, every second of my experience up here.
Hello, Luca. My name is Gerarda Gallo. I'm a math and science teacher from Giovanni Falcone School, Grottaferrata, Roma. We can all imagine your emotion moving away from the Earth and living in an environment so different to what we are used to. Well, I wish to ask, do you think going beyond means adapting to a new environment and perhaps finding a new planet to live on? How does your experience as astronaut help you appreciate our Earth and see an opportunity to make it better? Thank you so much.
So as I said, going beyond can have any meaning you want. Going beyond doesn't only apply for motion. It's not only about exploration. It can be about internal, inner exploration. So you can apply that meaning to anything, to any difficulty, any obstacle, any kind of limitation that you find in life. Does it mean also exploring for new planets? Why not? In the future, I certainly don't want to impose any limitation on that kind of possibility. Anything that we can think is possible, at least in my opinion. Do we need to do that right now? Well, in the future, if we keep expanding the way we are expanding on Earth, we will run out of resources. So we are going to have to find resources on different planets, or on the moon, or on asteroids. So is that going beyond? Yes, it's going beyond our capabilities of today. How do we do that? We do that by employing science, by employing technology, ingenuity, by having exploration as a way to go beyond what is currently our limit. But yes, I don't think it's a contrast when I say that going beyond is also understanding that what we're doing on Earth right now is damaging our only planet, the only resource for life that we know. And we have to go beyond what we're currently doing in terms of energetic resources, in terms of limiting our CO2 emissions. We have to go beyond our current plans in order to keep our planet viable. Not for life. Life will continue. Life will continue well beyond we are gone. But we are facing a mass extinction for many species, including man, because of our own incapability of seeing beyond our present times. So yes, going beyond from the space station also means looking down and thinking, we need to put our resources into saving this planet, into understanding that it doesn't belong to us. It belongs to an whole ecosphere, and everybody's part of it. Thank you for the question.
Thank you, Luca. We'll now switch over to Spain for 2 questions. Spain, please go ahead.
Hi, Luca. I am Diego Garcia, teacher at FEIP Federico Garcia Lorca, Guabejar in Granada, where we work with 3D printing and educational robotics. Nice to greet you. On Earth, we have created remote control robots that can walk, roll, and even fly. What role do you think this type of advanced robots will have in the future of exploration?
So we already have robotic exploration, and as a matter of fact, ESA's program is called Human and Robotic Exploration because we think that they go hand in hand, or hand in robotic hand. They're not in contrast, and right now robotics is incredibly important. Think of the discoveries and the research ongoing on Mars through Spirit, Opportunity, and Curiosity. They have done tremendous job exploring and visiting the ground for us. We have a European robotic research program, Mars Express, where currently we have an orbiter around Mars analyzing the atmosphere. So I believe that in the future, this cooperation between human and robotics is going to increase, is going to get even better, because the intelligence of the robots is going to make them more independent, is going to make them better adapted, is going to make them more reliable. So what we see here is a way where probes, robots, rovers open up the way for us to understand the environment before we go in and try to do our own exploration on the ground. Now, there are several limitations to robotics exploration that humans don't have, and vice versa. There are limitations to human exploration that robots don't have. So I believe that the two things should be really integrated. ESA is doing really a lot of work into integrating human and robotic exploration, and I think that in the future it's going to be even more so. Thank you for the question.
Hello, Luca. My name is Agustín Torres. We come from ES Gildestático in Jaén, Andalucía, south of Spain. Our question is, microbes play an important role in life on Earth. All microbes taken for Earth need to be prepared to withstand environment conditions in space, and specifically on other planets. Thank you.
So yeah, no, we really understand the microbes and the microbiome is a vital part of our environment and ecosystem. We study our own microbiome up here on the space station to understand what changes happen to the microbes when they are in a macro G environment, and they do change. There is gene expression changes, there are behavioral changes, there are reproduction changes. So we are currently studying those to better understand what happens at the macroscopic level when you leave the known safety of Earth, and you go in an environment that's completely different. I don't know if where we are with the modification, it would be more that would be more of a question for an astrobiologist. I do think that the research in going into the way of exploiting the capabilities of many microbes of living in extreme places. We have extremophiles in all kind of different environments on Earth. There are extremophiles that like high acidity place. There are extremophiles that like very base place, extreme hot, extreme cold, extreme pressure. So all those characteristics we understand are found elsewhere in the universe. So the more we understand the microbiology of these of our world, the more we can infer what kind of environment we can find in other places. Now, to counteract that, we have to understand that it's also part of what we're looking for. We're looking for life, so we need to understand the microbiome world in order to be able maybe to recognize life once we find it somewhere else in the universe, because we always imagine aliens being green men with little antennas. I don't believe that that's what we're going to find, but I do believe that it's going to be something very similar to what we understand because of the physical constraints of the universe. And the microbial world is probably what the closest example that we can find of something that is probable existing elsewhere in the universe.
Thank you very much, Luca. Unfortunately, we don't have time for any more questions, so I'll hand back over to you for a quick goodbye to all of our connected sites.
I want to remind the students that ask me the questions that you are the future of science, technology, and exploration. Your questions are so important because it shows your ingenuity and your curiosity. keep that curiosity alive. Curiosity is what made most of us astronauts be here today. We just wanted to explore. We wanted to find out new things. You have that flame. Your teacher are fanning that flame so that it become a fire of curiosity and future exploration. We trust your generation to come up with the question and the answer that we need to be better humans in the future. So thank you for your question. Thank you for coming up here. Thank you for pushing me beyond my own limits of knowledge, and I'll see you soon, and thank you again.
Station, this is Houston ACR. That concludes the event.
Thank you to all the participants from ESA station. We are now resuming operational audio communications.